from University as a PhD student in the Department of Biology. First of all, I would like to thank the organization committee to hold us together in this lovely and wonderful congress. Today, I would like to talk about the investigation of adrenomedullin effects over hypoxia inducible factor 1 alpha under hypoxic conditions in rats. As context, I will start to give information about the background and aim. Then I will introduce our materials and methods related to our research. Then I will show our results. Finally, I will give some take-home messages about our research. First of all, adrenomedullin, which was first discovered in the tissue isolated from pheochromocytoma in 1993, is a vasodilatator peptide consisting of 52 amino acids. Pheochromocytoma is a Greek word, and pheos means dusky, chroma means color, and cytoma means tumor. Adrenomedullin is mainly synthesized in medulla, also myocardium, then lungs, central nervous system, endothelium, vascular smooth muscle cells, and also adipose tissue. Adrenomedullin is a biologically active peptide that has various effects, including vasodilatation, the regulation of vascular endothelial function, inhibition of cardiovascular alteration, adjusting adipogenesis, and decreasing insulin resistance. In depriving of oxygen supply, also known as the hypoxia conditions, adrenomedullin provides enough oxygen to reach tissues by expanding the blood vessels as a vasodilator peptide. Also, the other parameter we want to research was hypoxia inducible factor 1 alpha. It is a subunit of a heterodimeric transcription factor of hypoxia inducible factor 1. The other subunit is hypoxia inducible factor 1 beta actually. This hypoxia inducible factor 1 alpha is a master transcriptional regulator of cellular and developmental response against hypoxia. The dysregulation and overexpression of hypoxia inducible factor 1 alpha by either hypoxia or genetic alterations have been heavily implicated in cancer biology, as well as a number of other pathophysiologies, specifically in the areas of vascularization and angiogenesis, emerging metabolism, cell survival, and also tumor invasion. And our aim actually was to investigate the response of the organism when exposed to hypoxic conditions and the effect of adrenomedullin over hypoxia inducible factor 1 alpha levels. For the materials and method parts in our research for adrenomedullin and hypoxia inducible factor 1 alpha levels, we used rats, and we used these rats heart, kidney, and lung tissues. Also, we have 4 groups in this research. One of them was the control group, the other was hypoxia group, the third one is control plus adrenomedullin group, and for the last one, hypoxia plus adrenomedullin group. This is the hypoxic condition provided plexiglass cabin, which we used in our research. As you can see from the size, dimensions, also we use oxygen tube. The normal control group was oxygenated with normal air. And for the rats in hypoxia groups, we use to provide hypoxic environment containing of 10% oxygen and 90% nitrogen for 1 week. For the rats in adrenomedullin groups, we injected intraperitoneally in a dose of 1.25 nanomole per kilogram for 4 days before collecting the tissues from dead rats. For the control and treatment groups, We used actually 7 animals for the control group and 8 animals for the treatment group. Then adrenomedullin and hypoxia inducible factor 1 alpha levels were measured in taken of their tissues using ELISA method, also known as immunoassay method. Here are our results. In order to comment from our results, we have to perform one-way ANOVA tests to detect the diversities between these groups, and p-values has to be lower than 0.05, considered to be as statistically significant. As you can see from the graph, adrenomedullin levels in hurt tissue decreasing hypoxia group when compared to the control group, the blue one. Also, the adrenomedullin levels increased in hypoxia plus adrenomedullin group when compared to the hypoxia group. For the kidney tissue, adrenomedullin levels decreased in hypoxia and control plus adrenomedullin groups compared to the control group, the blue bar. Also, we, as I told you before, we used lung tissue from the rats. We observed that the adrenomedullin levels increased in all groups when compared to the control group. Another parameter, as I told you before, was hypox-induced factor 1 alpha, hypox-induced factor 1 alpha. That was the level of it was decreased in hypoxia plus adrenomedullin group, and also hypoxia-induced factor 1 alpha levels decreased in hypoxia group when compared to the control group. The other tissue was kidney, in terms of looking the levels of hypoxia-inducible factor 1 alpha. And the level in kidney was the highest in control plus adrenomedullin group compared to the other groups. And as you can see, the star above the green bar, there is also a difference between hypoxia plus adrenomedullin with the control group. For the last tissue, we used lung. In terms of hypoxia inducible factor 1 alpha level, the highest one was the control plus adrenomedullin group compared to the other groups. And also, hypoxia inducible factor 1 alpha levels in treated groups compared to hypoxia and control groups was also increased. So from these data, we can say 3 take-home messages. One of them was adrenomedullin has a role in angiogenic process, and our experiment showed that adrenomedullin may react earlier than hypoxia inducible factor 1 alpha and affects its synthesis. For the second message, we can definitely say that tissues respond to hypoxic conditions in different times, and we realized that lung tissue may respond earlier than the other tissues we studied. For the last message, organism increases its vascularization as a response against hypoxic conditions, and adrenomedullin treatment may provide a rapid adjustment to overcome this hypoxic condition problem. Here, these are a few images related to our university, and I would like to thank you for listening to me. If you have questions or any suggestions, I welcome.